Types of matrices. We have various types of matrices, but which are given in your basics. Will do only those here. Out of those, first we have row matrix. From the name it is clear, row matrix has only single row. It may have as many columns as possible, okay, but row will be one. Few examples are given, like A, it has one row and two columns. B has one row and three columns. Okay, so what is row matrix? Which has only single row, one row. Column matrix, only one column, and rows it may have as many. Example, A and B are there. So A has only one column, but it has three rows. So this is a column matrix. Square matrix, from the name it is clear, its length and breadth will be same. That is, it will have same number of rows as number of columns. Examples, this A and B, it has three rows and three columns, so it's like a square. B, it has two rows and two columns. You can say its order is 3 into 3, or you can say A is a square matrix of order 3. It's same. Next is diagonal elements. Diagonal elements are elements where I is equal to j, that is row number is equal to column number. Okay, diagonal elements are those elements where row number and column number is same. For example, suppose A is a square matrix. Then if we draw a square, suppose we say this is diagonal, this is also a diagonal, it's okay in the figure, but in the matrix diagonal elements are only those where row number and column number is same. Just check which element this is. This is A11. So here row number and column number is same, so this is called diagonal element. This is A22, 2 is equal to 2, so this is also a diagonal element. This is A33, so this is also a diagonal element. If we consider this, what about this 7? 7 is A13. Here 1 is not equal to 3, so this is not a diagonal element. Okay, similarly this 3, this is A31, again it's not diagonal element. Okay, so we consider only those elements as diagonal elements where row number and column number are same. Next we have diagonal matrix. A square matrix is called a diagonal matrix if all the non-diagonal elements are 0. That is, Aij is 0 for all I not equal to j. For example, in this case, A and B. In A, we have these as leading diagonal elements, and except these, each and every element is 0. So it is called a diagonal matrix. In this case also, except this diagonal elements, we have other elements as 0. So we call them diagonal matrices. Next we have scalar matrix. A diagonal matrix is called a scalar matrix if all the diagonal elements are same other than 0. They should not be 0. For example, A and B. Here we have all other non-diagonal elements 0 because it's a diagonal matrix, but with one condition, that diagonal elements are same. In diagonal matrix this condition is not there, but here diagonal elements should be same with this matrix of order 3. So it is a diagonal matrix, which in turn is a square matrix with all diagonal elements same except 0. Next we have identity or unit matrix. A scalar matrix, it is a scalar matrix which in turns it is a diagonal matrix. That means it is also a square matrix, but with the condition that elements, these diagonal elements will be equal to 1 or unity. Okay, it will be a square matrix, it will be a diagonal matrix, it will be a scalar matrix, along with a condition that these diagonal elements will be equal to unity. I hope it is clear. Next we have null matrix. A matrix with each and every element as 0 is called a null matrix or a zero matrix. For example, okay, all the elements are 0. Then we have lower triangular matrix. A square matrix is called a lower triangular matrix if all the elements above the main diagonal are 0. Okay, we have understood what are the diagonal elements. Then above the main diagonal, if elements are 0, we call it lower triangular matrix. So these are the examples. You can see, if I draw like this, so it looks like a triangle and it is towards the lower side, so we call it lower triangular matrix. Same is the case with this example. And all the elements above this diagonal are 0. Same in this case. Next we have upper triangular matrix, just opposite to lower triangular. Here we have all the elements below the diagonal will be 0. Okay, Aij is 0 for all I greater than j. Okay, this is a triangle. That's why it is called upper triangular matrix, because the elements below this diagonal are all 0. So I guess it is sufficient for today. So today's homework is go through this and solve sums which are given after this video, and also solve similar sums from your book. Tomorrow we'll get back with the next topic. Till then, goodbye, take care.